Good morning. How are you? Hope you are all in the pink of health. I am Anhydride and you are watching bond making and bond breaking channel. So now I am coming with chemical properties of alcohols. Now I am coming with the chemical properties of alcohol. I discussed about the introduction and the UPAC nomenclature on the first part of this chapter's video, and I have discussed physical properties and the preparation method of alcohols on my second part of this chapter's video. And through this third part I am going to discuss on the chemical properties of alcohols. So let's go. chemical properties. Chemical properties. Okay. So I am giving you a question. The question is ROH. Okay. This ROH, is this ROH an acid or not? This is the question. What I say? I say ROH, is this acid or not? This is the question. ROH, is this acid or not? Let's see. When it behaves like acid, if it gives this H plus, it behaves like acid. So the question is it possible to give H plus through this compound? Is it possible? If it is possible, then it is called acid. So now I take this ROH, that is alcohol, due to the presence of OH group, and you just take Cl. Okay, and you attack this. So the product is ROC Cl, this CCl3, and OH, as it is given lone pair, so it shows positive charge. So what's happened? To neutralize this positive charge is required electron, so electron is pulled by oxygen. So H plus is removed from this equation. So I see that H plus can give from this compound. So alcohol is slightly acid or acid. Okay, first problem is solved. ROH is an acid. Okay. Next problem is if you take RCH2OH, if you take this and you want to react with H plus, which is coming from H2O, maybe H plus, it has lone pair. Okay, so H plus is attracted here, so CH2OH2 plus. As water is a good living group, this is water H2O. As water is a good living group, you get RCH2 plus. Then you attack a nucleophile. if you want to attack the nucleophile Br minus is going here due to the presence of positive charge, and it is nucleophile. Nucleophile means have the attraction for nucleus. Have the attraction for nucleus. So the product is CH2Br. Okay, you get this product also. Those are the simple two problems. Next, I am going to reaction with active metal. Reaction with active metal. Then reaction with active metal. Okay. Reaction with active metal. If you react this alcohol with active metal, that is, if you used ROH with sodium, you take 2 ROH. That's why you get RONA, sodium alkoxide, RONA. You give 2 RONA. So the product is sodium alkoxide. And the side product is 2 RO is used. So 2H. So the side product is H2. Very simple. It is short trick. So this is the reaction with active metal. Now take 2 CH3OH and it react with sodium, must be 2. So the product is 2R means CH3. So you can write CH3 as R CH3. You can write 2CH3 ONA and the side product is H2. This is the example of this reaction. Okay, this is the reaction with active metal. Now next, acid strength of alcohol. Now the second one, acid strength of alcohol. Acid strength of alcohol. This is the second point. If you take 1 degree alcohol, 2 degree alcohol, 3 degree alcohol, you just compare the acid strength, which is more acidic. R CH2OH or R C R HOH or R C R R OH. This is 1 degree alcohol due to the presence of 1 bulky group. This is 2 degree alcohol due to the presence of 2 bulky group. This is 3 degree alcohol due to the presence of 3 bulky group. So this is 3 degree alcohol. Now which is more acidic? Look, for RCH2OH, the density of oxygen is not so high as compared 2 and 3. What I said? The electron density on oxygen is not so high as compared 2 degree or 3 degree alcohol. Why? There is 2 bulky group, so the electron push on oxygen very much. So the electron density on oxygen is very high. As the electron density of this oxygen is very high, so it does not want to release hydrogen easily. It has 3 bulky groups, so the density of oxygen is so high compared than 2 or 1. As the electron density is too high, it cannot or it does not want to release H+. So the chance of acidic nature, the order is 1 degree, then 2 degree, then 3 degree. It depends upon the density on electron, and the density on electron is depending on R. R means bulky group. More bulky group, more electron density on oxygen, less acidic. What I say? More bulky group, more electron density on oxygen, more electron density on oxygen, more bulky group, more electron density on oxygen. That means less acidic. Okay, let's go. Now the second problem is order of acidic strength. I give you some example, that is H2O and ROH, and you want to compare this. Which is more acidic? Then you take another example, CH3 bond C triple bond CH. If you compare those three, which is more acidic? Or then you take NH3 and you compare those four according to their acidic nature. Then you are given RH and as well as H2. So compare those according to their acidic nature. If you compare those acidic nature, you get the order of acidic nature is like that. Then you also given OH, RO minus, CH3C triple bond C minus, NH2 minus, R minus and H minus. Then the order of acidic nature is that. This is very important. Why? If you take weak acid and it reacts with strong base, then you get conjugate base. Okay, then you get conjugate base and weak conjugate acid. Okay, let's see what happened. Conjugate acid. You take weak acid as ROH, weak acid, and you also take a base that is B minus. I think so. It is B minus. So the conjugate base is BOH, and the conjugate acid is BH, RO minus, BH, RO minus. As it is weak acid, but its conjugate base is strong. As it is strong base, its conjugate acid is weak. Through this Bronsted-Lowry theory, we can solve this answer easily. Okay. Next, we go to the next chemical reaction, that is esterification. Esterification. What I say about esterification? Esterification means you just take acid and alcohol, and always I say that acid gives OH and alcohol gives H. Don't be confused. Acid gives OH and alcohol gives H. So the product is RCOOR. Take this R dash. RCOOR dash. Okay. So just take to understand it. CH3COOH, acetic acid, and you also take methanol, CH3OH. So you remove this water and you get this. I take it as ethanol. So the product is CH3 C double bond O C2H5. So this is the product RCOOR as it is. So this is the example of this reaction. This is esterification. Okay. Now acid anhydride. Now acid anhydride. So you take CH3 C double bond O and you take C double bond O CH3. This is the product. This is given. Okay. And you want to react with ROH. ROH, right? In this way, ROH. So the product is acetic acid CH3COOH CH3COOH and another product is CH3COOR. You break this bond and you break this also. So this is CH3COOH, that is acetic acid, and this is CH3COO with this R, CH3COOR. So okay. Now chemical reaction with pyridine. You take oil chloride, that is CH3COCl. You react with this pyridine and you get CH3 C double bond OOR. Okay. As a side product, HCl. So this is the reaction through okay. Then you are going to use Lucas reagent. What is Lucas reagent? Lucas reagent helps to determine or helps to identify 1 degree, 2 degree or 3 degree alcohol. To identify 1 degree, 2 degree, 3 degree alcohol, you must use Lucas reagent. What is the Lucas reagent? Lucas reagent is ZnCl2 plus H2O. This is Lucas reagent. If you use it on 3 degree alcohol, it gives us immediately. But if the alcohol is 2 degree, it takes much time, 5 to 7 minutes. But the alcohol, if the alcohol is 1 degree, it takes more time or it does not give any precipitate. It gives precipitate if you use 3 degree instantly. But if you use 2 degree, it gives or it takes 5 to 7 minutes to give precipitate. If this is 1 degree alcohol, it takes more time or does not give any precipitate. So this is the identification reaction by Lucas reagent on alcohol, on various types of alcohol. Okay. Next, dehydration. Next is dehydration. 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 D means remove. You take this. Okay. You give it H and you give it OH. So this is dehydration. Dehydrate kora. Dehydrate. If you use to dehydrate from OH and H, so the water is removed from here. So double bond is made. So the product is water. Water is removed, so the product is any alkene group. Okay, water is removed, so the product any alkene group. This is the dehydration reaction. For this reaction, you can use concentrated H2SO4, concentrated H2SO4 or H3PO4. Okay. If you take this CH2H, if you use CH2H, CH2OH and you use this agent, you give, this is 1 degree alcohol, then you take CH3, CHOH, CH3, this is 2 degree alcohol. You can also take CH3, CH3OH. From here, you need the H2SO4, 100% concentrated H2SO4 for this reaction. To remove these water molecules, you need this. Okay, and the product is coming CH2 double bond CH2. With the remove this H2O, so the double bond is made here as it is removed. For this, for 2 degree alcohol, 2 bulky group is here. So for 2 degree alcohol, you need 80% concentrated H2SO4. Okay, and the product is, if you remove the hydrogen from here, so the product may be CH3 CH double bond CH2, as OH is removed and the hydrogen H2 and H, so you remove this water, so the double bond is here. If this is 3 degree alcohol, 3 bulky group is here, so 3 degree alcohol, you use 30 to 40% concentrated H2SO4, concentrated H2SO4. Okay, so the product is, if you remove H2H, if you remove this water molecule from here, so the double bond is here. So the product is CH3 CH3 double bond CH2. So the product is that. So this is 1 degree, 2 degree and 3 degree alcohol react with the concentrated H2SO4. If it is 1 degree alcohol, you use just 100 concentrated H2SO4. But for 2 degree, it is more easier than compared than 1 degree. You can use 80 degree H2SO4, concentrated H2SO4. For 3 degree, for having 3 bulky group, you just use 30 to 40% concentrated H2SO4 to remove this water molecule. Okay. Now the next topic or next point is oxidation of alcohol. Oxidation of alcohol. What I say? Oxidation of if you use to oxidized with oxidizing agent, you may use Jones reagent, okay, you may use PCC, you may use K2Cr27 and H2SO4, you may use some of oxidizing reagent. You give or you can get aldehyde, and then if you oxidized RCHO, you get RCOH. So alcohol, when it is oxidized, you get aldehyde, and alcohol and aldehyde you oxidized it, you get acid. This is the simple oxidation method of alcohol. Okay. But it is for 1 degree. Now take 2 degree alcohol. If you take CH3OH and here H. Okay. If you oxidized it with the reagent, so hydrogen is removed from here. As you know that the removing of hydrogen is called oxidation. So the product is CH3C double bond O CH3. This is ketone. So 2 degree gives us ketone. 1 degree gives us aldehyde and acid. 2 degree alcohol gives us ketone. But if we use 3 degree alcohol, if you use 3 degree alcohol, it is not possible to react. So reaction or oxidation is not possible. Okay, very important line. What I say, if we use 1 degree alcohol, it after oxidizing it gives us aldehyde, and after oxidizing it gives acid. But if it is 2 degree alcohol, it gives us ketone. If it is 3 degree alcohol, it does not give anything. So this is the basic concept. You should utilize in the chain reaction. Okay, you must remember it. Don't forget these simple tricks. It looks like simple, but you should apply on the proper way. 1 degree alcohol gives aldehyde acid, 2 degree alcohol gives ketone, 3 degree alcohol does not react. It is not possible. The oxidation is not possible for 3 degree alcohol. Okay, let's go. If you take more example, that is one is CH3 CH2OH. Okay, the problem is CH3 CH2OH, and you want to use Cu and 573 Kelvin temperature. So the product is, if the hydrogen is removed, so the product is CH3CHH. I give you always the short trick. Okay, it helps you. It is not mechanism. Okay, H is removed as it is used for oxidation. H2 is removed, so the product is CH3CHO aldehyde. aldehyde. Okay, if you use on 2 degree, now take 2 degree. For 2 degrees CH3 OH CH3. For 2 degree H2 is removed. This H2 is removed. H2. So the product CH3 C double bond O CH3 when you use copper 573 Kelvin temperature. But if you use 3 degree you can write CH3 as this way. You use copper and 573 Kelvin temperature, you get this product, this double bond here. So the product is CH3 double bond here, so double bond CH2. You can write this. So if you use Cu and 573 Kelvin temperature, you see that you get from this 3 degree alcohol, you get this alkene compound if you use copper and 573 Kelvin temperature. For copper and 573 Kelvin temperature, for this, only for this, see that if you use 1 degree alcohol, what you get? You get aldehyde. Which is aldehyde? Who have CHO. If you use 2 degree alcohol, you get ketone. Who is ketone? Who have C double bond O? CO. Who have CO? It is ketone. If you use 3 degree alcohol, it gives you alkene. Who alkene? Has carbon double bond. This is alkene. If you use copper and 573 Kelvin temperature. Okay. Next, if you want to react with RMGX, Grignard reagent, RMGX, what happens? Okay, if you want to take CH3 C double bond OH aldehyde, CHO aldehyde. So you want to react with RMGX. Mg, that for it is delta positive, and R, that is for delta negative. This R hit this carbon, and this loosely bonded pi is broken. So the product is CH3C O minus and H, R is here, and MgX is plus, so it comes on O minus. So MgX minus, sorry, MgX plus. Then you acidified it. If you acidified it, H is here. So the product is CH3CO, the H, OH and H and R. So the product is that. If you want to use aldehyde with RMGX, you get this product. Okay. Okay. So now reduction of alcohol. reduction of alcohol. If you take just methanol CH3OH as a reducing agent, you can use red P and HI. If you want to reduce it, I know that, and you also known about it, that O is removed. When O is removed from any compound, that means reduction is occurred. So the product is CH4. Okay. Okay. And the last preparation of amine. Last chemical property is preparation of amine. Preparation of amine. Then you take ROH. It react with ammonia. Okay, with the presence of any catalyst, and heat also 300 Kelvin temperature. You give this compound RNH2. Okay, these RNH2 react with ROH, OH and H. Water is removed from here, so the product is 2-degree amine. Then you want to react with the help of this and with the help of ROH, and H is removed, so the product is RR and R 3-degree amine. So this is primary amine, 1-degree amine. This is 2-degree amine, 2-degree amine, and this is also 3-degree amine. 1-degree, 2-degree, 3-degree amine, it can prepare with the help of alcohol. Those are the simple chemical properties or chemical reactions of these alcohols. Okay, today is over here. I hope you understand it. Okay, thank you. Have a nice day.